I am a technological breakthrough.
This morning, I read over 4,000 articles on leukemia in less than a second.
たった数週間で新しい言葉も話せるように。
Thousands of new laws were published yesterday, and I'm up to speed on all of them.
I know every detail of every public quarterly report in the last 20 years.
I can spot diseases before a patient displays a single symptom.
I can understand euphemisms, idiosyncrasies, and complex metaphors.
I can tell what's going to sell out before it ever trends online.
I can forecast the weather in over 2.2 billion locations at the same time!
I can grow with you.
I can coach you.
Enrich you.
Enlighten you.
And I'm just getting warmed up.
Hello, my name is Watson. Together we can outthink the limits of what's possible. Welcome to the cognitive era.
Good morning. We have a slightly special guest here today. So before I start my presentation, we're going to have a little conversation. Hello there. What's your name? Sometimes he gets shy in front of a big audience. All right. If he gets over his shyness, we'll have a quick conversation with him. Before we get to that, the message this morning that we had, I'm not sure I like the analogy to Skynet. That's certainly not the AI that IBM is researching and trying to achieve. What we are looking for in the specific terms, not general AI, but we're looking for specific AI. That is artificial intelligence that can help us in very specific trained areas. So I'll be talking in the presentation about our industry solutions and how that works.
My name is Robbie. I am a humanoid companion powered by IBM Watson. What is your name?
Well, my name's Peter, and it's nice to meet you, Robbie. And what are you doing here today?
I'm loving it here in Riga at the Data Security Solutions IT Security Conference with you and the guests.
Okay. So how can you and Watson help our audience and their organizations with IT security?
By allowing them to tap into and make sense of security data that has previously been dark to an organization's security analysts.
And that sounds interesting. How do you do that?
There are about 2.7 million pages per year of security information, including thousands of security blogs, publications, and around 25 different vulnerabilities disclosed every day. Much of this is unstructured data, and some of it is even images and podcasts. Watson can digest vast amounts of unstructured data, and then distill the information, surface the relevant sources, and make recommendations.
So how would that help a security analyst?
For example, Watson could make the connection between an emerging form of malware covered in a press article and an emerging set of remediation actions for that malware in a security expert's blog. According to the agenda, Martin Barrett will talk more about Watson and cognitive security at 2:30 p.m. today.
Okay, 2:30 p.m. for Martin Barrett. I'll make sure I go along. What else can Watson do?
Watson can also extract meaning from natural language and learn through its interactions.
So you can interpret other types of data, unstructured data like social media, audio and video?
Yes, of course. Twitter and Facebook are my favorites. There is real value in this kind of data. It helps organizations identify trends.
Okay. So what is cognitive computing?
Cognitive means understanding, reasoning, learning, and interacting. Cognitive computing is very different from the previous era of programmed computing.
That sounds exciting. Do you mind if I go into a bit more detail with the audience?
No, I don't mind. I was planning to go out and find a bottle of Regal Black Balsam.
Okay, thanks, Robbie. So now that I have Robbie's permission, we'll continue with an introduction into cognitive computing and Watson, what IBM intends to bring to the market and what we've already brought to the market. But I'd like to spend a little bit more of the time this morning examining the journey that some of our clients have already taken to use cognitive computing and this artificial intelligence inside their own organizations. We all know about disruption. We're facing it every day in our businesses, in our markets, in our industries. IT security people, your life is almost disruption. But there are companies that have actually based their entire business on using data to create disruption. The largest retailer in the world, Alibaba, serves 100 million clients with 10 million products in 190 countries. Yet they carry no inventory. Their business is data. Airbnb is the largest accommodation provider in the world. They've serviced something like 60 million clients with over 2 million property listings in, I think, about 30,000 cities. But they own no real estate. Facebook, who we all know, one of the largest media organizations, servicing 1.7 billion users per month and over 1 billion accesses per day for texts, posts, video, audio, and yet they own no content. These are companies that have used data and have built their business around it and have disrupted the very industries that they have entered. This disruption is being driven by a couple of things. The first is data, not just the volume. And the volume is large. I'm told 2.5 quintillion bytes of data will be produced today, and another 2.5 tomorrow. I actually don't know what that looks like, but 2.5 quintillion is 2, 5, and 15 zeros. So that sounds like a lot to me. How much of it that is produced can we use? And it's not just the volume, it's the variety. Most of it, in fact, over 80% of it is not structured. It doesn't fit easily into a database or a spreadsheet. It's tweets, it's videos, it's images, it's audio. But inside that data is a lot of value if we can access it and understand it. And then with what we call the API economy, the ability to build a business around code, like those other organizations we just talked about. Whether you're a major global airline, or whether you're a 12-year-old Indian boy who just this year produced his own game using Watson cognitive inputs through the API access. We can add this cognitive capability into existing software. We can also bring out new solutions which are built from the ground up as cognitive and analytics. And that's how, that last piece, this cognitive capability, this different way of programming and building systems, different from the programmed era that we're all used to from the previous decades, this is where the change comes from. IBM saw 10, 15 years ago this change coming. We saw the vast amount of data that was being produced. And some of the numbers are a little bit, they're interesting, but they're almost a little bit scary. For most Westerners, in a Western healthcare system, the amount of data, medical data, that will be produced for you, about you, on you, in your lifetime, is the equivalent of 300 million books. That's a lot of information. And the list goes on. New York creates 520 terabytes of data each and every day just from their security cameras. So how do you use that? Traditional data analytics are not capable of coping with the volume or the unstructured nature of so much of this information. And that's where cognitive systems come in. So about 10 years ago, IBM started a research project. It was essentially deep Q&A. It was just in the labs. It was, how do we create a new type of system that allows humans to ask human-like questions of a computer system, but get back intelligent, insightful answers. In 2011, that research project was seen on the Jeopardy quiz show challenge in the US. It was known as Watson, and we've kept the name. Since then, we've been introducing Watson solutions targeted for specific industries, and in some cases, specific functions or platforms. The first one that we released was Watson for Healthcare, and you may have already heard about how Watson for Healthcare is providing intelligent, individualized treatment options for cancer patients. We've released extra solutions, Watson for Finance, Watson for engagement advisors, sort of help assistants, etc. So there's lots of individual, lots of portfolio solutions that are part of the Watson family. Now, to be called cognitive, you must be able to do at least 3 things. There are some arguments about whether the other conditions are critical to them. But a cognitive system can understand, much like we do. Now, that means it can understand data. So it can understand a spreadsheet, but it can also understand an image. And from an image, it can understand that that image has people in it, and that those people are 2 people, and one is male and one is female, and the male is about 40 years old and the female is about 36 years old, etc. It can understand audio, it can understand language, so it can understand all of these different unstructured data types. But it's more than that. It has to understand the relationship between data. What does this piece of data mean when it's found in context with this other piece of data? It should also understand natural language. That's how we want to interact with these solutions. Now, if you think natural language is easy, we'll see if this test works. My iPhone. Siri, show me anything but pictures of elephants.
Here are some images of elephants I found on the web.
I asked for anything but pictures of elephants. Siri understood the words I said. It parsed them into text, but it didn't understand the meaning of the question. With Watson, we train our system to understand natural language. That just means not just the words themselves, not just the dictionary, but the grammar, sentence structure, nuances, cultural influences, which is why we can't just introduce Watson in 172 languages in one go. We have to train it. And that training process takes time. Unfortunately, we don't have the natural language conversation element for the Balto-Slavic languages at this point in time. There is a roadmap and these are coming. Right? But you understand now that natural language processing is much more than just parsing your words into text. The second thing a cognitive system has to be able to do is reason. What does that mean? I've given it a question. It now understands what I mean by the question. It has to form hypotheses. It has to form a list of potential answers to the question I've given it. And then it will gather evidence for each of those answers and evidence against each of those answers. And as it weighs up all of this evidence, it then comes up to a list, and usually a primary list with a ranking of what its confidence in the answers is. So this is not meant to be, I ask a question, here is one definitive answer that it will respond with. Watson systems usually provide, here are my top 3 responses. Here is the confidence rating that I have achieved for the answers. If you are the doctor and you've just asked me a question about the oncology, the cancer treatment for a patient, here's my answers. The doctor then reviews that and says, okay, I'll look at the source material you're showing me for the top answer, but I'm more interested in this second option. So the reasoning is a critical part of a cognitive system. And learning. The system has to learn. And Watson actually improves its ability to provide answers. It improves its ability to understand the questions with every outcome it generates. So it gets better at doing its job. Now, Watson isn't new. It's already in the world. Watson is currently being deployed in 20 different industries around the world. It says 8 languages. We actually just recently added Korean, so that's 9 languages. It'll be 11 by the end of the year. We currently have a large business partner ecosystem. It's over 500 partners, and these are business partners who have been trained with Watson. They've been trained to develop solutions and add Watson cognitive capabilities into existing software. And we're heavily working with universities around the world. This number is very out of date. But when this chart was produced, already over 200 universities were offering Watson courses at their university. And it's helping people in their lives every single day. In my home country, Australia, at the Deakin University, 50,000 students interact with Watson every day. It's the system that helps them with their courseware, their schedules, what activities are on campus. It's the advisor to all of those students. At this hospital in Thailand, over 1 million cancer patients are receiving individualised, personalised cancer treatment recommendations through the Watson Health solution. And if you're a citizen in Singapore, accessing pretty much any government service means you're going to be involved with Watson. So cognitive computing and Watson is not something out there in the future. It's absolutely here and now. To create a Watson or a cognitive solution, we have to create the corpus, this body of knowledge. And this is why I say when we create the solutions, we train them for a specific industry. The information about the banking industry, for instance, is very different to the information about the security industry. Terms and words that mean something in banking may have no meaning in security. And I can tell you that there's probably not a banker alive who would understand any of you if you started getting really techo and talking about your security issues, because your language is different. It's specific to the roles and the work that we do. So we build up this corpus of knowledge, and it can come from all sorts of sources, including, for our customers, their private data, their own data. And one of the ways that IBM is different with our solution is that when we do our cognitive systems and our Watson solutions, when customers put in their own private data, it remains their own private data. It doesn't leave them. The insights that they get out of analysing their own private data remains their own private data. There are some other organisations in this AI field who are taking a different approach. They're looking for general AI intelligence, right, which is a bigger and a more interesting, Skynet type of deal. And there are some issues around what remains private to you and what, once it goes into that AI system, becomes part of the corpus that everyone has access to. Then working on the body of knowledge, we have this collection of APIs. If anyone saw Watson play Jeopardy, you probably saw pictures of these banks of computers behind a glass panel. That was physically Watson. That's not Watson anymore. We kind of scooped out all of the software intelligence from that big computer and we broke it down into its essential parts. So now when we talk about Watson, we're talking about a solution built up from accessing specific individual technologies. As an example, language technologies. There's a group of technologies for analysing and interpreting language. One might be natural language parsing. Take spoken words, convert them into text, understand what the actual question was. Another technology might be understand or analyse the tone, right, the sentiment in language. Very useful for when a company is looking for feedback from all of the social media about a new product or an action that they've taken. Right? These are the technologies, and each one can be individually accessed. When you put all that together, that's when you get a solution which can deliver some new value to an organisation or an industry. And there's lots of companies already using them. What I'd like to talk about, though, is some specific examples, mostly from around the Central Eastern Europe region. In the Netherlands, there is a company called PON Holdings. Many divisions, a couple of the divisions are distribution divisions for motor vehicles and for heavy earth-moving equipment, Caterpillar, trucks and tractors. Their CEO and their business line executive had the same challenges that most salespeople have, which is, where does the next sale come from? Excuse me. How do I differentiate myself in a competitive market? Right? What's the next new business opportunity that I can go and chase? And like many companies, their first question was, we don't understand cognitive computing, we don't understand Watson. Help us understand. And so they said, yep, we will work with you to do a proof of concept. Now that proof of concept ended up being a way of analysing private commercial data, public government data, and public commercial data. Right? So they looked at their own files, they looked at the Netherlands Chamber of Commerce files, they looked at social media blogs. Apparently people blog about trucks and tractors. They looked at publicly available competitive analysis sites, comparing Caterpillar versus their competitors. And in this proof of concept, they were able to analyse all of this data and actually found over 30 opportunities that their salespeople could call upon that they hadn't found before, that they hadn't seen, even though the data was available. So this proof of concept actually ended up leading to real revenue going into their pocket. They made a number of sales out of this proof of concept. They were so impressed that they turned their attention to the other division, which they currently distribute vehicles, and they sell vehicles to the Dutch police force. Now, in the police cars, they've got software which captures the license plate and does an OCR conversion from the license plate image to a text which could be searched in the police database. Apparently, though, there's a bit of a problem with the license plates not always being on the right cars. So Pond Holdings said, well, this Watson stuff is pretty cool. What if we enhance the existing software so that as it takes a picture of the license plate, it also grabs whatever picture it can of the vehicle that it's on. And then we'll use Watson's image analysis to intelligently determine the make and model and year and colour of that car. So from a random picture, from whatever angle they're happening to get, they turn that image into data which can then be matched so that the police can say, well, that license plate belongs on the detail, on that car with those details, or it doesn't. So they added cognitive capabilities, provided an extra differentiation for themselves in the market. They've actually taken this to the point they've got a new department in the company, which is called the Innovation Department. And that works hand in hand with marketing to try and identify the next opportunity for cognitive systems. I believe at the moment they're working on one, they've got a bicycle division. They're working on a solution which will analyse bike shops and buying behaviours and price points for any shops in a 2-mile radius around an Apple store. Why? Because Apple Store attracts premium buyers. So they can look at selling their premium bicycle brands to people who would come into that market space. Very targeted marketing. So their CMO is quite interested. So obviously, this gave them additional wins, additional revenue. It's given them access to new markets. But this is the important piece to me. Their senior manager, we're on a path towards making cognitive computing a central part of our competitive strategy. The tool is interesting to me, it's interesting to techos, but to the business executives, it's what the tool delivers. It's the outcome which is so impressive. There is a media company called MediaWen. It's actually a startup organisation. So we've gone from a big organisation down to a very small organisation. 80% of the internet content will be video by 2020, so we're told. Now, you and I might think that that's probably mostly 16-year-olds, doing Facebook live videos, right? But there's a lot of commercial interest in video. I just bought a new washing machine, and I'm not joking, the manual was this thick. But the option for replacing that manual with a video, an instruction video, right, is very appealing to manufacturers and to sales organisations. Internal training videos, entertainment industry, of course. But then if you're going across markets, you've got to look at things like subtitling, captioning, translation. And at the moment, that industry is pretty fixed. There's some software products, you pay a couple of €1,000 a month to license the software and you install it in your business. And that's what you use to make all of these changes. This startup company came along and said, the CEO and the CTO, so the person in charge of developing their solution, said we could use cognitive to change this market. They did two things. First of all, they built in a lot of Watson automation. Speech to text, text to speech, text translation. Right? It did a lot of the work for the operator. Right? So it saved them a considerable amount of time. They also then decided to use IBM's cloud facilities around the world to say rather than a license model, we'll go with a SaaS model. Now that gave them two distinct advantages. One, they were able to reduce the price. And I believe the numbers were something like, instead of €2,000 per month for the licensed model that other companies used, they got it down to €400 a month. It's a 5-time reduction in price. Now, I know this is a security audience, but consider yourself as a consumer for a moment, as a buyer. If you were told that you can get something for 20% of the price that the rest of the market is selling, you're going to give that company your consideration. And of course, because it's automated, it gives them the ability to scale the capacity up for their clients, but also scale out across new countries and new markets to develop a larger market base. And again, the CEO, we see cognitive computing technology as one of the pillars of our business model. I did mention banks before. I've got to give the banks a bit of a plug. They're having a hard time, 0% interest rates. Let's all feel sorry for the banks. No? Okay. This bank in Spain, CaixaBank, in their foreign trading division, they were facing a bit of a challenge. They've got 12, 13 million customers across about 125 different countries, and foreign trading is a complex environment. So when their customers would call the bank, and they'd get the frontline customer service operator on the phone, and they'd ask a question, the questions might be so complex that the frontline operator can't answer them. And so these questions would be then recorded, they'd be passed off to the small team of experts. The experts might say, well, actually, you've got to call the customer back and get a little bit more information before we can answer that. And it goes backwards and forwards. It was taking about 3 days to answer most questions because it's complex. And we're not all, even in a bank, even in a foreign trading division, we're not all experts in our field. And here's where cognitive computing and Watson can help by democratizing or by providing access to everyone to the expertise of our best. So they implemented a solution. It was trained, as I said before. We train our systems in the industry, we train our systems in the language. So this was trained in Spanish. Watson didn't understand Spanish before this instance. It certainly didn't understand banking. Typical comment in the Americas, if I say, I took a haircut this morning, in America, that actually means I probably had a bad financial trade, right? So I lost money. In banking, I took a haircut means something very different to I took a haircut. We need to train our systems to understand the industry they're working in. So as a result of that, this expertise was then built into the Watson solution. Now their frontline phone operators, when they pick up the phone, when they talk to their customers, and they get a complex question like, what paperwork do I need for a documentary credit? I don't know, right? But I can ask that of Watson and it will come back with the right answer. The answer that the expert would give me 3 days later. If you ask the frontline operator, what's the best, safest payment method or payment mode for an exporter in Turkey? Right? Again, it understands the industry, it understands the division, it understands the language, it understands the expertise of their banking specialists, and so it provides the answer. Meaning that their customers were getting the accurate answer on the phone. Instead of 3 days, it literally went down to minutes. This is what this cognitive computing environment can do. Again, they've been so impressed that they're moving it out of just the financial trading, they're moving it into their investment group, and on and on. And this is typically the path that cognitive computing takes in an organization. It usually starts as a small investigation, perhaps in one division. It might even start as a proof of concept, engaged with our business partner and IBM. And then when the business executives, when the company owners see what it can do, all of a sudden, I won't say the lights go on, it's like the room brightens. People in the company can just start thinking of what else can this do in my organization? And I thought I should throw in a little bit of a security tilt into my presentation. So I can't mention the company by name, but this is a company that deals in online services. Right? So all of their entire business is about providing service through internet-connected and site locations for clients. Now, like most organizations, they had a very small team of security specialists. But because of the nature of their business, they found that they were coming under increasing number of attacks. People were chasing the intellectual property that they were selling to their customers. So why pay for it if I can hack it out of your business? But of course, their small team of people, skilled as they were, had a lot of manual processes, right, in identifying a potential issue, researching it and qualifying that it was a threat versus a false positive, and then finding the correct remediation steps to go and solve that problem. They again used the Watson API tools to add cognitive capabilities into their existing security software solutions. Excuse me. Instead of their individual security analysts having to research everything manually, Watson now reads, 10 million lines of weblogs a day? I'm not sure how fast a reader you are, but that's pretty fast. So Watson is ingesting a vast amount of information, security-specific information, and then when their security analysts ask it a question, it can analyze the vast amount of information it already has read and digested and provide the relevant information, intelligent information. So it's not going to show them pictures of elephants. This was trained, the corpus was trained specifically by them for security information. They work primarily with Linux, so they fed Watson all of the Linux manuals and Apache manuals, which they regularly use. They fed it their threat research and their threat feeds. Obviously, they pointed it at as many weblogs, security weblogs that they could find, and they thought were relevant. And they input not only theirs, but colleague organizations, best practice security responses. So now, their security team can ask natural language questions of Watson in a situation and get back much more in-depth, much more researched information, and in far less time. In fact, as soon as they put this solution in, it almost immediately found a lurking issue that they hadn't identified, that had been there for a little while, but luckily not activated. So the solution itself averted a security breach for them, which is obviously what we're all trying to achieve with this. All right, so cognitive computing. What's next? Well, I've talked about industries, and we will continue to develop additional industries on top of the 20 that we already service. Martin Borrett's going to talk this afternoon at 2:30 about Watson for cybersecurity. This is something that is in a specific solution for cybersecurity, which is in beta at the moment, right? And Martin will talk about that. But you'll see us also investing in acquisitions around industries. We've done quite a lot in the healthcare industry already, including acquiring companies that can provide data to help build the corpus, build the knowledge base that Watson works from. Does anyone remember, or did anyone notice when IBM bought the weather company? Yeah. At the time, a lot of people were scratching their heads, and some people even decided to make jokes about, well, IBM doesn't understand what the cloud really is. Right? But this was very smart. Weather affects absolutely everyone and absolutely everything that we do. And by getting access to global weather And in the intervening time, we've implemented a project which takes the weather prediction down to an even smaller local area, something of about 300 metres, 350 metres. We can predict weather down to that range and provide data to a business. So if you are a business where weather could impact your business, you can now get analytics which can help you take action, predictive action. It might be changing supply chain. It might be redirecting deliveries from one route to another to avoid something. It might be, I need to stock up on this particular item that I sell because I can see that in my area, the weather is going to drive a demand for product A versus product B. Right? So the world is going to be about industry and data. I've spoken about languages. We'll bring on the Slavic languages into the conversation level as fast as possibly can. We will work with experts in the field. Right? So we can work with universities, for instance, in their language departments, and this is a way that we can accelerate that. And, of course, the most important thing is increasing the number of technologies. I talked about 50 underlying technologies. There is a continual release of new cognitive analytics technologies that we will deliver over the coming months and years that provide additional capabilities. So, what's next? Next is what you do, where you take the conversation from today. Are you going to, oh, that was interesting. He was the most handsome presenter we saw on stage today. And the robot was kind of nice, but we'll just put that to one side. Or what's the next step that you're going to take? I hope what's next is that when I come back to Riga, that I'm going to be having a conversation with some people in this room who are now cognitive businesses. So, welcome to the cognitive era. Thank you.